My name's Steve Michell. I'm a senior lecturer in molecular microbiology here at the University of Exeter.
Can you tell us a little bit about your career path so far? So how did you get to this stage?
Actually, I trained as a chemist at Imperial College London, and as part of that degree, I was fascinated by organic chemistry and sugars and carbohydrates, things that we eat every day or have in our coffee. And this was back in the late 90s, and what we discovered was that there are sugars on the surface of bacteria in the forms of these things called glycoproteins. And that led me then to study these in bacteria, and it was found that these glycoproteins, these proteins with sugars added to them, were prevalent in pathogenic bacteria, that is, bacteria that cause disease. And on the back of that, that's how I got into looking at bacteria that cause human diseases. And ever since then, I've been interested in all aspects of bacterial virulence or bacterial diseases, including antibiotic resistance and especially vaccines. So my contribution to this project is looking at the models in the laboratory of virulence. So what that means is making sure that these phage, these natural predators that we're identifying from the environment, can actually tackle these clinical pathogens in the laboratory.
So does that mean you can visualize this? I mean, can you see these things?
Absolutely. So what we have here at Exeter is a model, an infection model with wax moth larvae called Galleria melanella, and these are little larvae, and we can infect these with clinical pathogens that fluoresce. And then when we add the phage, what we look for is a reduction in that fluorescence, and that's an indicator that these phage might actually work in an actual patient. So that's our first screen.
That's really cool. So you could actually see the change in the colour of these things.
Absolutely. You can see a reduction in the intensity of bacteria that are prevalent in these larvae following infection and then following treatment with phage. So these things, this project, the Citizen Phage project, so we're talking about bacteriophage. These are natural in the environment. There are many more phage than there are bacteria, and there are many, many more bacteria than there are humans on this planet. So what phage are, they are natural predators of bacteria. They are viruses of bacteria. They're not viruses of human beings at all. They're very small, and they do to bacteria what things like COVID and influenza do to us. They can destroy, actually, the bacteria. And given the crisis that we have with infectious disease and the prevalence of antimicrobial resistance at the moment, this is a real opportunity and avenue for different potential treatment options. There is a massive problem with antibiotic-resistant bacteria at the moment, and these pathogens that are resistant to these antibiotics unfortunately seem to be prevalent in patients with chronic diseases. For example, children and adults with cystic fibrosis, they normally have these chronic pulmonary infections, and because these diseases are managed with antibiotics, they just become resistant. So there's not really an end point to treating these diseases, unfortunately, with antibiotics, because continued treatment with antibiotics just develops the resistance in those chronic infections. So this is a real potential new way of treating effectively these chronic infections. I think the biggest concern is not convincing people, but changing awareness and current opinion of the idea of using a virus to treat a bacterial infection. I think with the passing of COVID over the last 2 years, the word virus strikes a lot of fear into individuals. But what these are phage, really. It's very rare that we actually call them viruses. We always call them bacteriophage, and that's their correct name. They're natural predators. But current awareness is that viruses are not a good thing, but viruses against bacteria, hopefully will be a solution to several diseases in the future. I think the thing about the phage is that in contrast to antibiotics, which can be broad spectrum, so you just asked about what effect it might have on the microbiomes, the population of bacteria that we have within us. Antibiotics that we take, that the population in the world take routinely, they actually can cause quite a lot of collateral damage to our microbiome. The thing about these bacteriophage is that they're very specific for the particular pathogen. So that's why we want to screen lots and lots to identify a particular phage for a particular pathogen. And that hopefully would reduce some of that collateral damage that you see with antibiotics. One of the biggest hospital infectious disease for elderly people is something called Clostridium difficile. And that actually that bacteria causes diarrhea, but it causes diarrhea in the elderly because they have their microbiome damaged by taking antibiotics. And then this bacteria, Clostridium difficile, comes in and proliferates in the absence of the natural microbiome and causes disease that way. It's a citizen-based project that it'd be great to have people out there giving us the samples, and we're doing this in collaboration with many public engagement groups and surveys, etc. But also there's an app called What 3 Words, so we'll be able to identify where it came from, and the people who send it in, we can give those any phages identified from those people, their name, etc. So we want it to be totally inclusive. And what's beautiful about this project is we're working really closely with the clinicians at the Royal Devon and Exeter Hospital who've got an interest in this and want to see this developed. And I think a lot of it is about raising public awareness and hoping that the public will see this as a beneficial potential treatment in the future.